In today's lesson, we are going to begin our trigonometry unit. The trigonometry unit involves three angle measurements. So we're going to be looking at triangles because we have three angles, right, in triangles. And more specifically, in this year, we are only going to be looking at right triangles. We're going to be looking at triangles that have a 90-degree angle. And so we need the concept of a similar triangle to understand trigonometry. So in grade 9, you learned that triangles are similar, not congruent. Remember, congruency means that the two triangles are exactly the same, right? So even if they're in different orientations, we could rotate, flip, and then overlay them, and they'd be identical. So that means two triangles are congruent or exactly the same. Similar is not true. They are not exactly the same, okay? But they are in relation to each other in proportion. One triangle has been scaled up or scaled down. So they take the same shape. So if two triangles are similar, their sides are in proportion. For example, 3 multiplied by 2 is 6. 4 multiplied by 2 is 8. So all of the sides have been doubled, scaled up, right? It's twice as large. When you scale up and scale down a triangle, the angles don't change. Those angles remain the same, right? Because we had that triangle within, right? If this was 3 and this was 6, that's a right angle, that's a right angle. This was 5 and the whole thing was 10, etc. This is 4, this is 8. This triangle matches with this triangle, and those triangles are the same, right? So they are similar triangles. They are in proportion, okay? So similar triangles, we can see, have sides in proportion. 4 divided by 3 is 1.3 repeater. 8 divided by 6 is equivalent to 4 over 3, or 1.3 repeater, okay? That ratio, it doesn't matter how big or how small you make this triangle, the ratio doesn't change. The sides change, but the ratio, this side divided by this side, remains constant. It's a 1.3 repeater ratio for this particular angle. You'll notice it doesn't matter how big or small I make that right triangle, that angle remains the same and this ratio remains the same. This is the basis of our trigonometry unit, understanding that this ratio is known for all particular angles. Okay, so if I had an angle of 20, I would know what that ratio is. Or if I know what that ratio is, I know what angle it is. Okay? And we're going to learn all about that this chapter. So we're going to start on our tangent ratio. And we're going to define what two sides create this ratio, right? There's 3 sides, right? So we only want to take 2 out of the 3 to create the ratio. So the 2 sides we're going to take for the tangent ratio is the side opposite the angle as compared to the side adjacent the angle. So if I'm talking about angle A here, then I'm going to take the side opposite to angle A. Well, the side opposite to angle A is over here, right? If this is angle A, my side opposite of angle A is going to be side BC, right? I name the side based on the endpoints, the vertices, right? B to C or C to B, whichever way you want to name it, okay? The side adjacent means next to or beside it, but it's not the hypotenuse, it's the other leg, okay? So if this is the opposite to A, then adjacent would be here, which is next to, but not the hypotenuse, right? It's the other leg that makes up the 90-degree angle, which is adjacent. So if I asked for the tangent of A, meaning the tan ratio of angle A, it is equal to BC, opposite, divided by CA, adjacent. Okay? If I changed it, instead of focusing on A, I focused on angle B. That was my point of reference, or I'd say my reference angle. My side opposite changes. My side opposite is now AC, or CA, and my adjacent is now BC, right? So you can see the tangent ratio depends on our reference angle. Our reference angle is always one of our two acute angles. Okay, our reference angle would never be our 90-degree angle. It always has to be one of our angles less than 90 degrees, which is one of those two. All right, so let's practice finding the tan ratio. Here's a multiple choice question. The tan of A, so here's A, is what? Which one of these four? The tan of A is opposite as compared to adjacent, 5/12. There we go. Let's try the next one. The tan of A, there's A over there, is opposite as compared to adjacent, 9. I don't see 12/9. Oh, look at my ratio could also be reduced or changed to a decimal or changed to a percentage, right? There's lots of ways to write a ratio. But I see 4/3 in my answer key right there. All right, the tan of B, this time I'm focusing on B, is going to be opposite, right, as compared to adjacent. This time my adjacent's there, I just change the orientation, right? The opposite and adjacent are the legs, not the hypotenuse. So 1 divided by 1 is just simply 1. There we go. And then the last one, the tan of A, there's A, I focus on that. That tells me where to focus, my reference, opposite over adjacent. And then I can reduce it, divide by 2, divide by 2. Oh, there we go. Okay, so we can now find the ratios. We can define our tangent based on a particular angle. We can find the ratio. If I gave you the ratio, could you draw a diagram? For example, if the tan of A is 7/10, could you draw a diagram to represent it? Sure, well, you'd have to start with a right triangle. However you draw that right triangle, it doesn't matter, as long as you have a 90-degree angle, and there you go. Then you'd have to define where A is. Well, it has to be one of the two acute angles. It really doesn't matter where you choose. It could be here or here. So you pick one of the angles to be A. 7 is the side opposite A. 10 is the side adjacent to A. And you could find the hypotenuse if you wanted to. You just use the Pythagorean theorem, right? So by knowing the ratio, you know the sides of your triangle. Okay. What if I made your ratio 0.25? Well, you could still do it. You draw a triangle, a right triangle. You would define one of your angles to be B. And then your opposite would be, well, 0.25 you can make into a fraction lots of different ways. You could just make it over 1 and call the opposite 0.25 and the adjacent 1. Or you could have made it 1/4, called the opposite 1, the adjacent 4. You could have made it 2/8, called the opposite 2, the adjacent 8, or 25/100. There's infinite equivalent fractions that create this ratio. So there's infinite similar triangles when you know the angle B, right? For this particular angle, right? So you can draw the triangles. If I told you tan 25, asked you to calculate it, you go into your calculator, making sure it's in degree mode. Gotta make sure it's in degree mode. If it's in radians or gradians, you will not get the right answer. So you always have to make sure your calculator's in degree mode. And every calculator is a little different. Some calculators you type in tan 25, some calculators you type in 25 tan. You need to figure out how your calculator works. So test it on your calculator. You should be getting on your calculator to 4 decimal places. If it asks you to round to that, I get that. So if you're not getting that, then you need to ask for help from someone with your calculator or double check the mode. It needs to be in degree mode, the D on top in your calculator. If I want to know what this number represents, this number is the ratio of opposite as compared to adjacent. You could just draw a picture. This time I know my angle, so I put 25 in one of the angles. That's my reference angle, is 25. Opposite to 25, make that a fraction, is my 0.4663, and adjacent is 1. So now I know my opposite side is a little less than half my adjacent, right? I can visualize that and see the relationship between the two sides just by looking at that ratio. Okay, it just tells you how those two sides are related. Okay, so now we're going to do there's two main ideas with trigonometry. Number one, I could give you the ratio and you have to find the angle to that ratio, or I could give you the angle and you have to find one of the missing pieces in my ratio. Okay, so let's start with just the angle. We're going to just focus on finding the angle. Okay, so if I tell you, so now we're going to use this little symbol, a little zero with a line through it. It's a Greek letter called theta. It's just like x in algebra. It's a very common variable, which usually means we're finding a missing angle. Okay, so I would say the tan of theta, you always have to say the tan of an angle equals a ratio, right? And the angle's in brackets. Tan can never just, it's just not, tan doesn't mean anything. You have to have the tan of an angle equals a ratio. So you always have to have an angle attached with tan. If you don't know the angle, then you need a variable attached to tan. So tan of an angle, I don't know what that angle is 0.5095. That's my ratio. Okay? So when you know your ratio, you can work backwards to find theta. We'll just use our algebra skills. So our algebra skills are, we have to undo what's happening. Just like if I had 2x equals 6, I undo what's happening to x by dividing both sides by 2, right? And I get x is 6 over 2, and then I can calculate it. Well, same thing here. How do you undo tan? You undo tan by doing tan inverse. Tan inverse undoes tan and wipes it out. So it wipes out on that side, but you have to take the tan inverse of this side. So if you look on your calculator on your tan button, you'll have above it a tan inverse button. So you have to probably go shift, hit that button, and that will pop up. So if you take the tan inverse of a ratio, you get an angle. Okay, so that's the key. If you know the ratio and you want to find the angle, you need tan inverse. Okay, and then you'll get 27 degrees. Let's try one more. Tan theta equals this ratio. So to find theta, I have to do the tan inverse, right? This, I don't write tan anymore because tan inverse undid it and it's gone. But I have to write it on this side. And there you go. Now I just go to my calculator, I type that in, 1.4653, and I get theta is 55. If I want it to the nearest degree, I'd round it up to 56 degrees. Okay, so that's finding an angle, but I don't always just give you the ratio. Sometimes you have to find the ratio first. So in this case, if I want to find this angle, I first need to find the ratio. So what is the tan of theta? Well, the tan of theta is defined as the side opposite as compared to the side adjacent. So the ratio is 4 over 10, or 0.4. So to find theta, I take the tan inverse of the ratio. I don't even have to write 0.4. I can just leave it as a fraction, and when I type it into my calculator, I go tan inverse bracket 4 divided by 10 close bracket. Right? That's nice and accurate. And so I get 21.8 degrees, or rounded off to the nearest degree would be 22 degrees. We'll try one more. We'll find alpha here. Tan of my unknown angle, so I use a variable, equals 4 as compared to 3. Therefore, my angle is equal to the tan inverse of my ratio. And again, we just type that into our calculator, and we get tan inverse bracket 4 divided by 3 closed bracket. I get, let's do this one to the nearest degree, 53 degrees. All right, so that's finding the angle. Now we're going to move on and we're going to find a missing side. Okay, it's the same idea. We use a formula, the tan of an angle equals the opposite side divided by the adjacent side. There's 3 unknowns. There's 3 pieces to that formula. There's one angle and 2 sides. We plug in what we know and we solve for what we don't know. So I know my angle. So now I would say the tan of my angle, which I know, tan 55 equals opposite, which I don't know, so I use my variable, as compared to adjacent. There you go. You have your formula. You write it out. Now, don't pick up your calculator ever till the last step. We have to solve for b. So if b is being divided by 7, we need to multiply by 7. Whatever you do to one side, you do to the other. Okay? That will cancel. So now we pick up our calculator. I've isolated b is 7 multiplied by tan 55, or we can just go 7 tan 55, and that means to multiply. And now I get 10 equals b. So we plug it into our formula, and then we solve for our variable. Okay, so that's what happens when, let's just zoom out so I can see everything. Let's try this next question over here. So if I was to write this one out, I would get, here's my angle, the tan of 62, the tan of my angle equals, I'm just following my formula, what I taught in the beginning, opposite as compared to adjacent. But this time a is on the bottom. So how algebraically do I solve if a is on the bottom? Well, I first have to undo a on the bottom. So if I multiply this side by a, it cancels. But whatever I do to one side, I do to the other. So far I have a tan 62 equals 10. Right? I multiplied both sides by a. Now a is being multiplied by tan 62, so I'm going to divide both sides by tan 62. When I divide the left side, it's gone, cancels out, but I have to divide the right side as well. So I end up with a is 10 over tan 62. 10 divided by tan 62, and I get, and again, you're practicing this on your calculator because every calculator is different. You're making sure you're getting this answer on your calculator. All right, if you're not, you got to fiddle with it and figure out how to type that in to get it. Okay, let's try 2 more. Here's my angle. I would say tan 57 equals opposite over adjacent. H is on the top, so it's being divided by 30, so I have to multiply the right side by 30. It cancels out. I multiply the left side by 30. Whoops. And now I just type it into my calculator. 30 tan 57. I get 46.2 is the height of the tree. And over here, 30 degrees. So the tan of 30 equals opposite, across from, over adjacent. A is on the bottom, so I multiply both sides by a. So I'm going to get a tan 30 equals 7. Now I'm going to divide both sides by tan 30. A equals 7 over tan 30. Okay, so I'm minimizing what I write, but it still makes sense. So 7 divided by tan 30. And I'm going to get a to equal 12.1 if it's to the nearest tenth. So that's finding a missing side. Your side could either be the top part of the ratio, or your missing side could be the bottom part of the ratio. That's the only 2 options, right? So we now know how to find a missing angle if you know the ratio, the 2 sides, or you know how to find a missing side. You should also be able to draw your triangle. We have a ladder leaning against a wall, and it forms an angle of 63 degrees with the ground. So when you draw your diagram, don't forget to draw the ground, right? And walls, which are 90 degrees to the ground. And then you put the ladder in, right? There's my ladder. And it says that the ladder makes an angle with the ground. So since the ladder and the ground are meeting, that's where the angle is. So you got to put in all the information you know. The ladder reaches, the foot of the ladder is 2 meters from the wall. Okay, the foot of the ladder is 2 meters. That's the foot of the ladder. It's 2 meters from the wall. So I'm going to put my 2 meters in there. And then you put your unknown. What are you trying to find? How far up the wall will the ladder reach? Well, I'm trying to find this distance right there, so I'm going to let that be h. Now that you have your diagram, you can do what we did before. You can just solve for it. Okay, well, the tan of 63 equals my opposite over adjacent, right? Opposite over adjacent. And then, therefore, h is 2, multiply both sides by 2, tan 63. So I just type in 2 tan 63, and I get 3.9 equals h. I now know that that height I can reach at 3.9 meters up the wall. All right, last question. What is the difference between these two questions? This is where most people struggle. Okay? They don't really understand the meaning of tan theta as compared to the meaning of theta. In this question, if I ask you to find tan theta, remember the tan of an angle. The tan of an angle is defined as a ratio, opposite as compared to adjacent. So the tan of theta, your answer should be a ratio. A ratio means it's a fraction or a decimal or even a percent, okay? Whereas theta is an angle. To find the angle, you need the ratio, right? But you take it one step further. So if I ask for tan theta, you just give me the ratio. There we go, done. That's the ratio. I could change it to a decimal or I could leave it as a fraction. I could even reduce my fraction. But that's all you need to do. If I ask for the angle, well, you need the ratio. You need to do what I just did, but now you need to take it that extra step and solve for theta by taking the tan inverse of the ratio. All right, and then you would type that into your calculator and you would take shift tan to get tan inverse bracket, 36 divided by 95 close bracket, and I'm getting approximately 20.8 degrees, or about 21 degrees is my theta. So make sure you know the difference between tan theta and theta when I ask for that.